Download this code from codegive.com, link in the description below. OK, buckle up. We're diving deep into the fascinating and somewhat complex world of advanced style transfer using the mad scientist node in a visual programming environment like comfyui, though the principles apply broadly to any similar node-based system. This tutorial will cover the core concepts, practical setup, code examples, mainly Python snippets you'll integrate, best practices, and troubleshooting tips. What is advanced style transfer? At its heart, style transfer is the art of taking a content image, the image you want to transform, and transferring the style of another image, the style image, onto it. Style here can refer to things like colors, textures, brushstrokes, and overall artistic composition. Traditional style transfer, as pioneered by gatys et.al., relies on optimizing the content image to match the content features of the content image and the style features of the style image within the feature space of a pre-trained convolutional neural network, CNN, typically VGG. Advanced style transfer builds on this foundation but introduces techniques to improve control. Gives you more precise control over what aspects of the style are transferred and how strongly they're applied. Reduce artifacts. Minimizes distortions, checkerboard patterns, and other undesirable effects common in naive style transfer. Handle complex styles. Deals better with style images that have intricate textures, patterns, or artistic elements. Incorporate semantic information. Takes into account the meaning and structure of objects within the images, preventing stylistic elements from being applied inappropriately. Real-time transfer. Achieves faster results with techniques like feed-forward networks that directly map content images to stylized outputs. The Mad Scientist Node, your creative lab. The Mad Scientist Node is a flexible, programmable node that lets you execute custom Python code within your comfyui workflow. It acts as a bridge between comfyui's node-based interface and the power of Python's extensive machine learning ecosystem, PyTorch, TensorFlow, scikit-image, etc. It's the perfect tool to implement advanced style transfer techniques. Key concepts and techniques. Before we dive into the code, let's review some important concepts you might use inside your Mad Scientist node. 1. Feature extraction networks, CNNs. Most style transfer methods leverage pre-trained CNNs, VGG16, VGG19, ResNet, etc. These networks have learned to extract hierarchical features from images. The earlier layers capture low-level features, edges, textures, while later layers capture high-level features, object parts, semantic information. You'll extract features from both the content and style images using these networks. Libraries like PyTorch's TorchVision. Models make loading pre-trained models easy. 2. Content loss. Measures the difference between the features of the content image and the stylized image. The goal is to ensure the stylized image retains the core structural information of the content image. Typically, this is calculated as the mean squared error, MSE, between the feature maps of a chosen layer in the CNN. 3. Style loss. Quantifies the difference between the style of the style image and the style of the stylized image. A common approach is to use the gram matrix. The gram matrix of a feature map represents the correlations between different feature channels. Matching gram matrices forces the stylized image to have similar texture and style correlations as the style image. Again, MSE is often used to calculate the loss between gram matrices. 4. Total variation, TV, regularization. A technique to reduce noise and artifacts in the stylized image. It penalizes large differences between neighboring pixels, promoting smoothness. 5. Optimization asterisk. Asterisk you'll use an optimization algorithm, example ATOM, LBFGS, to iteratively adjust the pixel values of the content image until the total loss, content loss plus style loss plus TV loss, is minimized. Asterisk PyTorch provides excellent tools for optimization. 6. Masking and semantic segmentation asterisk. Asterisk to apply styles more intelligently, you can use masks to restrict style transfer to specific regions of the content image. Asterisk semantic segmentation models, example using libraries like segmentation models PyTorch, can identify objects in the image. You can then apply different style transfer parameters or disable style transfer entirely for certain object categories. 7. Adaptive instance normalization, ADA-IN. Asterisk a more advanced technique that directly adapts the mean and variance of the content image's features to match those of the style image. This can lead to faster and more stable style transfer. 8. Feed-forward networks asterisk. Asterisk instead of iteratively optimizing the image, you can train a neural network that directly maps content images to stylized images. This is significantly faster for real-time applications. However, it requires a large dataset of content and style pairs. comfyui setup and workflow. Here's a step-by-step guide on how to set up your comfyui workflow and use the Mad Scientist node. 1. Install comfyui asterisk. Make sure you have comfyui installed and running. 2. Install necessary Python libraries asterisk within your comfyui environment, usually in the comfyui/python_embedded directory. Install the required libraries. 3. Create a new workflow asterisk. Open comfyui and start with a blank workflow. 4. Load images asterisk. Add 2 load image nodes, one for your content image and one for your style image. 5. Add the Mad Scientist node asterisk. Add a custom node, then select Mad Scientist. You'll need to install the Mad Scientist node if you don't already have it. 6. Connect nodes asterisk. Connect the image output of both load image nodes to the input of the Mad Scientist node. 7. Add a preview image or save image node asterisk. Connect the output of the Mad Scientist node to a preview image or save image node so you can see or save the results. 8. Configure the Mad Scientist node asterisk. This is where the magic happens. You'll write Python code within the node to perform the style transfer. Python code example, inside the Mad Scientist node. Here's a basic example to get you started. This example demonstrates classic style transfer using VGG19, content loss, style loss, gram matrix, and TV regularization. Explanation of the code asterisk. Asterisk imports necessary libraries. Asterisk configuration asterisk sets hyperparameters, weights for content, style, TV loss, which CNN layers to use, learning rate, etc. Asterisk these are critical. Experiment with these to get the best results asterisk. Asterisk helper functions asterisk. Asterisk load_image, loads images, resizes them, and ensures they're in RGB format. Asterisk gram_matrix, calculates the gram matrix for a given feature map. Asterisk TV_loss, calculates the total variation loss. Asterisk VGG model setup asterisk. Asterisk loads a pre-trained VGG19 model. You could substitute other models like ResNet. Asterisk freezes the model's parameters to prevent them from being updated during optimization. Asterisk image pre-processing asterisk. Asterisk defines a pre-process transform to convert images to tensors, and normalize them using the mean and standard deviation expected by VGG. Asterisk image loading asterisk. Asterisk retrieves the content and style images from the inputs dictionary provided by the Mad Scientist node. Crucially, it converts them to PIL images from the NumPy arrays comfyui provides. Asterisk resizes the style image to match the content image. Asterisk feature extraction asterisk extracts features from both the content and style images using the VGG model. Asterisk style gram matrices asterisk calculates the gram matrices for the selected style layers. Asterisk initialize stylized image asterisk creates a copy of the content image as the starting point for optimization. Asterisk optimizer asterisk sets up the atom optimizer to update the stylized image's pixel values. Asterisk optimization loop asterisk. Asterisk iterates for a specified number of steps. Asterisk calculates the content loss, style loss, and TV loss. Asterisk computes the total loss. Asterisk performs backpropagation to calculate gradients. Asterisk updates the stylized image. Asterisk prints the loss value every 10 iterations. Asterisk post-processing asterisk. Asterisk clamps the pixel values to be between 0 and 1. Asterisk converts the tensor back to a NumPy array and unnormalizes the image. Asterisk scales the pixel values to the range 0 to 255. Asterisk output asterisk sets the stylized image as the output of the node. Important notes asterisk. Asterisk input/output asterisk the Mad Scientist node expects a dictionary called inputs as input. The keys of this dictionary correspond to the input connections on the node. In this example, we connected two image nodes to a single input connection, so these are accessible as inputs 0 and inputs 1. The output of the node is a list named outputs. Asterisk image format asterisk comfyui uses NumPy arrays for images. The Mad Scientist node expects NumPy arrays. Inside the Mad Scientist node, you need to transform those images to tensors if you want to use PyTorch. Asterisk normalization asterisk make sure you use the correct normalization parameters for the pre-trained model you're using. VGG typically uses the mean and standard deviation specified in the code. Asterisk GPU asterisk the code automatically uses the GPU if available. Make sure you have PyTorch correctly configured to use your GPU. Asterisk error handling asterisk add error handling to your code to catch potential issues, example invalid image formats, CUDA errors. Running the workflow. Click the Q prompt button in comfyui to execute the workflow. The stylized image should appear in the preview image node. Advanced techniques to explore. 1. Masking asterisk. Asterisk add an input to the Mad Scientist node for a mask image. Asterisk multiply the style loss by the mask to apply style transfer only to masked regions. Asterisk use binary masks or grayscale masks for varying degrees of style application. 2. Semantic segmentation asterisk. Asterisk integrate a semantic segmentation model to identify objects in the content image. Asterisk apply different style transfer parameters to different object categories. Asterisk prevent style transfer for specific objects, example faces. 3. Adaptive instance normalization, ADA-IN. Asterisk implement ADA-IN to directly adapt the feature statistics. This is much faster than iterative optimization, but slightly more complex to implement. 4. Style blending asterisk. Asterisk use multiple style images and blend their styles together. Asterisk assign weights to each style image to control their relative influence. 5. Layer specific style weights asterisk. Asterisk assign different weights to the style loss for each CNN layer. This gives you finer control over the types of stylistic features that are transferred. Troubleshooting. Asterisk CUDA errors asterisk make sure you have the correct CUDA drivers installed and that PyTorch is using your GPU. Memory errors. Style transfer can be memory intensive. Reduce the image size or batch size if you're running out of memory. Slow performance. Use a GPU if possible. Consider reducing the number of optimization steps or simplifying the style transfer algorithm. AIN and feed-forward networks are faster alternatives. Unsatisfactory results. Experiment with different hyperparameters, content weight, style weight, TV weight, learning rate, CNN layers, etc. The optimal values will vary depending on the content and style images. Try different pre-trained models. Checkerboard artifacts. Increase the TV regularization weight. Use a better upsampling technique if you're using a feed-forward network. Lack of style. Increase the style weight. Try using more style layers. Make sure the style image has strong stylistic features. Content distortion. Decrease the style weight and increase the content weight. Conclusion. This tutorial has provided a comprehensive introduction to advanced style transfer using the Mad Scientist node in comfyui. By combining the flexibility of Python with the visual programming environment of comfyui, you can create powerful and customizable style transfer workflows. Remember to experiment, iterate, and explore different techniques to achieve the desired artistic results. Good luck, and have fun creating. Remember that the specific implementation will depend on the particular advanced technique you're using, so consulting the relevant research papers and code examples is highly recommended.